When you hear missile defense, it's easy to imagine one clean moment. A rocket goes up, hits another rocket, and it's over. But in real life, it's more like a lightning-fast chase in the sky, run by radar, computers, and split-second decisions. Welcome to the Smart Side. This channel is all about learning how things actually work. Today, I'll explain, in plain language, how Iron Dome and the Arrow systems intercept missiles, how they spot a launch, how they predict where it's going, how they decide whether to intercept, and how an interceptor gets guided to the right place at the right time. Let's start with the biggest idea. These systems don't aim at where the missile is right now. They aim at where it will be. Step 1. Detect and track. First, radar scans the sky and detects something moving fast. Once it locks on, it tracks the target continuously, basically taking rapid snapshots of its position, speed, and direction. With only a few seconds of tracking, computers can estimate the missile's path, its trajectory. Step 2. Predict the impact point. Now here's where Iron Dome gets misunderstood. Iron Dome isn't built to intercept every rocket. It chooses. If the system predicts a rocket will land in an open area, it may not fire, because interceptors are limited and they're saved for the most dangerous threats. But if the prediction says it's headed toward a city, homes, or critical sites, then the system engages. So the decision is basically ignore or intercept. Step 3. Launch and guide the interceptor. Once it decides to intercept, it launches an interceptor. And this is the part most people don't realize. It's guided almost the whole way. Radar keeps tracking both the incoming missile and the interceptor. And the command system sends guidance updates as the situation changes. Here's a simple way to picture it. Radar is the eyes. The command system is the brain. The interceptor is the hand trying to meet the target at the exact right spot. As it gets close, the interceptor switches into the final phase, making quick corrections to line up with the meeting point. Many interceptors don't need a perfect bullseye. They're designed to detonate close enough that fragments and the blast destroy the target. So Iron Dome, in one line, is fast detection, fast prediction, selective engagement, then a guided intercept. Now, Arrow is built for a different problem. What Arrow is designed for Arrow is meant for longer-range ballistic missiles. Threats that travel higher, faster, and in a steep arc. Almost like something launched up, then falling back down. That changes everything. You need earlier detection, you need longer tracking, and you need more precise prediction, because the speeds are extreme. The goal is usually to intercept as far away and as high as possible, so debris is less likely to fall near populated areas. There can also be extra complexity at long range. Sometimes the missile can separate into parts, and the defense system has to track the right object, the actual threat. Same logic, harder math. Even though Iron Dome and Arrow handle different ranges and altitudes, the logic stays pretty similar. Detect, track, predict, pick an intercept point, launch, guide, correct, again and again, until the final seconds. If you want the clean mental model, it's this. Missile defense is mostly math, plus fast control. Radar data feeds prediction. Prediction feeds a decision. That decision launches a guided interceptor, and the guidance keeps updating until the intercept happens. One last point, and this matters. These systems aren't perfect shields. They're built to reduce damage and save lives. By prioritizing the most dangerous threats and reacting in seconds, especially when many launches happen close together. So the next time you see an interception clip online, remember what you're really watching: a radar spotting a launch, a computer predicting the future, and an interceptor racing to meet its target with almost no room for error. If this helped you understand what's really going on, I'd really appreciate a like and a subscribe. It means a lot to me and to the channel, and it helps the smart side reach more people who love learning.